Okay, so now I'm going to present on tutorial 5. Okay, we're going to discuss on some of the questions that we have uploaded, okay, for tutorial 5. So the first question was, which of the following variables are categorical and which are continuous, right? So let me open one by one. So if you can see gender, all right, gender, of course it depends, right? It depends on how are you going to collect the data or what is the form of the data that you collect. That is why in the bracket we put example of the data, right? For example, if gender, if you're collecting categorical data, right? Basically this is categorical because you are collecting data in a form of categories which is female or male, right? So obviously this is categorical. Okay, age. If I'm going to collect the data in a form of years, right? So it is categorical as well, right? Okay, race, like for example, Asian, European, Indian or others. This is also categorical. Okay, if I'm going to collect a person whether it's smoking or not, if the data is in the form of yes or no, that is also considered as categorical. All right, systolic blood pressure, right? If it's measured in millimeters of mercury, right? So it is numerical value. Here, this is a continuous data. All right. And the last one, level of calcium in the blood. If it is measured in micrograms per milliliter, then it is also quantitative and it is in continuous data. Okay, now we are going to question 2. You are required to compare the size of several books. Describe some of the numerical variables that can be used to describe the size of a book. So what units would you use, right, to measure a size of book, right? So some of the example answers would be the numbers of pages, right? So number of pages. So you know that maybe some books are 10 pages, 20 pages, 30 pages or 100 pages or 200 pages. So if the unit is in the number of pages, so this can be used as the size of book. So other than that, there are many others. For example, number of chapters in a book, number of words in a book, right? The more words, maybe the book can be considered as larger or bigger, right? Same with number of pages. Weight or mass of the book, how heavy is the book, height or width and thickness of the book, and lastly the volume, right? Okay, question 3. Popular magazines often rank cities in terms of how desirable it is to live and work in each city. Now you have to describe 5 variables that you would measure for each city if you were designing such a study, right? So as you know, or you would have read, right, there are many surveys are done and then they have ranked cities on how good they are or how livable they are, right? So this is based on survey. They have, I'm sure they will identify some variables to measure to determine whether a city is livable or not. So if you are the one who's doing the survey, what are the things that you might put in your survey, right? So some of the variables would be unemployment rate, right? Because of course, if the employment rate is high in that particular city, it might be, or it most probably will be a more livable city, okay? Average mean or median of income, right? You want to know what is the average income. So even when before, even going to university, right? Sometimes you would have seen some students, they will choose where the location, besides the ranking, of course, they want to know what is the rank of the university, right? I'm sure a lot of you have looked at that before choosing a university. Other than that, some of them, if you believe it or not, they actually even look at the cost around the university. I mean, the cost of living around the university, whether it is suitable for them or not, right? Because of course, certain universities located in city centers, the cost of living is so high, to get rental is very high. But some universities are away from city and the cost of living is much lower and is very affordable, right? So there are many reasons why sometimes people choose, students choose specific university, right? Similar to that, maybe when a person is going to choose a city to live in, they look at how is the average income of people in that area, and then what they will do, they will compare what is the average expenditure for meals or groceries, right? I'm sure some of you, when you're looking for a job later on, you will check all these things, right? So these are some of the variables. Quality of public transportation, of course, right? You want to know whether the places are connected with public transport. Is it easy to get to go to one place to another? Is it easy to go to any important places, for example, hospitals, schools, right? Okay. Housing costs, of course, the rental, the purchasing of house, is it cheap or not? Crime statistic, this is also been looked by a lot of people. They will look at whether the crime rate is high or low in that particular area. And last not but least, of course, the facilities such as hospitals, schools, maybe other important banks, things like that can be part of the variables that you are look for when you are determining whether a city is livable or not. Okay, move to question 4. Okay, for the question 4, the following variables were measured on each fish. Okay, there's nothing much information given here. It is just mentioned that to measure a fish. Okay, and what are the units measured here? What are the variables measured here is, of course, the sex of the fish, the initial weight of the weight of the fish in grams, the body temperature of the fish in Celsius, and the weight gain of the fish in grams, right? So maybe there's an initial weight and there's a new weight, and we look at what's the difference to see what is the weight gain. So state the type of measurement scale for each of these variable above, right? So basically for sex, usually is either male or female, right? So this is actually is a nominal kind of data. Okay, initial weight, we suggest here it is a ratio. Okay, the reason is ratio variable has all the properties of interval. That means it can be ordered in a specific order from small to big, right? And then it also has a clear definition of zero. Okay, what it means here, zero is, maybe some of you might ask from previous classes, we do have questions like how there can be a fish without any weight, right? Here the zero doesn't refer to that the fish doesn't have any weight. It's just that there is no such variable at that point. Basically, maybe the situation was there's no fish to measure at that time. Okay, so it can be zero, right? So there is none that variable. That is what equals to zero. And another criteria that you must know, or another feature you need to know about ratio, is a ratio never fall below zero. Okay, but actually that is why some of you later on, even in exam or even during for your survey, for your group project that you're going to do, there is no right or wrong answer in terms of whether it's ratio and interval. Some students can somehow explain that some of these variables might not be even ratio, right? They might say that it is interval. It is fine if you want to explain it in interval, but provided you justify how the data was collected. That means in what format is the data is in, all right? Does it have a zero? Does it have does it have a zero, or will it go below zero? Because if it goes below zero, then it shouldn't be ratio. Okay, ratio value doesn't go below zero, right? So you look at these criteria. You can actually explain. You can explain that no, this will go below zero, so it cannot be ratio, right? Maybe you're talking about frozen fish, right? Frozen fish where people using for export import, and then when you take the temperature, of course the temperature might be below zero, right? Those are frozen fish. They keep it frozen at below zero for some reason, right? So that it lasts longer and all. So for that reason, maybe ratio might not be suitable. So that is why I'm not saying whether there's right or wrong answer for this. It depends on how you justify your answer. So every time, even in exam or test later on, when you are explaining this kind of questions, please mention, okay, you chose ratio. Why did you choose ratio? How do you look at the situation, right? That means how the data form is, right? So if you can justify that, then it is fine, okay? We accept such answers, right? Okay, body temperature, right? Body temperature in Celsius here, there is no definite zero, so it's an interval. Weight gain, in this case, I can explain that the fish at the initial stage and the later stage, when we took the weight again, there is no difference. That means the fish weighs the same. So if the fish weighs the same, that means there is no weight gain. So in this case, when there's no weight gain, the weight is the weight difference is zero. So in that case, I can say it is ratio. So that is how I explain my answer. So you might have different answer. Can is accepted provided you explain why you chose such scale for that particular variable. Okay, now moving on to question 5. Which of the following statements are true? Okay, this is quite simple. Can we just read through? Number 1 says all variables can be classified as quantitative or categorical variables. Second one, categorical variables can be continuous variables. Number 3, quantitative variables can be discrete variables. Okay, so the answer is E, right? So what is E? E is 1 and 3, which is all variables can be classified as quantitative or categorical, and quantitative variables can be discrete variables. So some explanation here. All variables can be classified as quantitative and categorical variables. Categorical variables, however, are not numeric, right? They are not numeric. So therefore, they cannot be classified as continuous variables. So number 2 is wrong, right? Okay. Number 3 is correct because discrete variables are indeed a category of quantitative variables, right? This is simple. I'll move to question number 6. Okay. So number 6, an auto analyst is conducting a satisfaction survey, sampling from a list of 10,000 new car buyers. So now you have a population of 10,000, right? The list includes 2,500 Ford buyers, 2,500 GM buyers, 2,500 Honda buyers, and 2,500 Toyota buyers. The analyst selects a sample of 400 car buyers by randomly sampling 100 buyers for each brand, right? So that means there are 4 groups here, right? 4 groups. Each of the group has the same criteria because they grouped it according to the type of car. And from each of the group, they take 500 buyers randomly. So the question is this an example of simple random sample? Okay, the answer here is no. Okay, I know there will be some questions like, why no, right? Because everyone has the equal chance of being chosen. Okay, there is some criteria in simple random sample that you need to know. Besides being random, right? That means each of these respondents or the subjects in the group of sample, right, is having equal chance to be chosen. Even in this case, the sample is 400, right? Now the sample that you've chosen is 400. So each of the sample of 400 car buyers that you form should have equal chance equal chance to be chosen, right? So for example, okay, let me just go through this answer, and actually I found a video which you would be able to relate to this by using a different example, okay? So every possible 400 buyer sample did not have an equal chance of being chosen. Okay, why? Is because, right, you must understand in simple random sample, it requires every sample of size n. In our case here, n is not 20 or not 250 or not 1000. The n here is the 400, the final sample that you have formed. Okay, n is supposed to be, n is 400 in this case. It has an equal chance of being selected. But in this problem, there was 100% of chance that you can get 100 purchases of each brand, right? From each different type of car, you can get 100 buyers, right? But there was a 0% chance that the sample would include a different kind of combination. For example, you cannot get a combination of 99 Ford buyers, 101 Honda buyers, 100 Toyota buyers, and 100 GM buyers. So this n equals to 400, although n is still 400, but this combination, okay, there was a 0% for you to have such sample, okay? Because here in this case, you are only taking 100, 100, 100, 100, right? So in this case, it is considered not simple random sampling. But there's something else which is more suitable to this. What is it? If you think about it, this is more suitable to be called stratified sampling method. As you know, what is the nature of stratified sampling method is you do grouping, right? Grouping according to certain common criteria. So in this case, there are 4 groups of cars with common criteria, right? And then you take a certain number of sample from each of these groups that you have broken into. In this case, there's 4 groups. I'm sorry, there are 4 groups. So thus all possible samples of size n equal 4 did not have an equal chance of being selected. So this cannot be a simple random sample. Actually, simple random sample, or called as SRS, is very simple, right? Very simple, meaning that if you have a population, without doing any categorization, you are basically taking, for example, certain percentage of members from that population to form a small sample. That is considered as simple random sample. That means every member in that sample has equal chance to be chosen. Okay, there are some other explanation which we will upload later on, these slides that I have done. So maybe if I could play this YouTube a little bit, that you can get some idea.
Random sampling. So here are a couple of different samples that we have taken from a larger population. Now the key element of simple random sampling is that each one of the different samples that you could get, in here there looks like they're about size 5, each one of these has equal probability of occurring. Also, each person has the equal probability of being selected. So again, each sample is just as likely as any other sample of being chosen, and each person has the same likelihood as being selected as another person. Now, it is possible to have each person having the same likelihood of being chosen as everyone else, and yet not each sample be equally likely as other samples. So let me give you an example to show you how. Let's say we have two groups of people. We got here 5 women and 5 men, and we're going to flip a coin. And if it lands heads, we're going to pick the group of all girls, and if it lands tails, we're going to pick the group of all boys. And so here we could see that it landed heads. And so we pick, for our sample, the group of all women. Okay, so now ask yourself, what was the probability of this woman being selected? 50%. It was a coin flip. What about this woman? 50%. What about this guy? 50%. What about this guy? 50%. So it was equally likely for any one of these people to have been chosen into the sample. So that meets this criteria here. However, each sample is not equally likely as any other sample. What is the probability of getting all women? 50%. All men? 50%. What about the probability of getting 3 women and 2 men? Well, in this scheme, this is not even possible. That's 0%. So here we would say that each sample is not equally likely, right? This is 50%, this is 50%, and this sample is 0%. So this would not be a simple random sample. Now, I'm not saying you'd never choose your samples this way, but I just wanted to use this to illustrate the point that you can meet this criteria and yet not meet this criteria. More often what you would do is you would just assign each one of these people a random number, and then through a random number table or a random number generator on a computer or a calculator, you would randomly pick who gets selected to be in the sample. So we randomly pick that woman, we pick this guy, then we pick this gentleman, this woman, and finally this woman. And so that's how we randomly pick a sample. And so this is called simple random sampling. Let me just say one more thing and put everyone back where they were. The roster, the eligible roster from which you could choose, that means the whole population from which you're choosing, there's a name for that, and that's called the sampling frame. So our sampling frame here is all of these people, and then we can randomly assign numbers to these people. And through a random number generator, then we could pick who we want to put in our sample. So in the next video, we're going to look at different kind of sampling called stratified random sampling.
Okay, then in that video, I just wanted to give you another example of why the particular example which was given in the tutorial is not considered a simple random sampling. All right. So the next question: explain 3 ways that statistic has been inappropriate interpreted and how to avoid it. Okay, for actually there are many, right? There are many ways statistic has been wrong misused, right? So for this example, I'm just going to show three, but you may be able to find more than that. Okay, so if you have given any answers other than these three, that is fine, as long as you can explain, okay, how they are misused. Okay, the first one, distorted percentage. So misleading explanation that uses percentage. People use a lot of percentages in order to confuse the buyers or the basically their customers, right? This happens a lot in businesses, right? So the ads, for example, there's an ad saying by the airline says, in terms of lost baggages, this area was improved 100% in the last 6 months, right? So actually this improvement of 100% is from what? What was the previous loss of baggages numbers, and how much is it now? So why are they saying improve of 100%? Of course, the moment you see 100%, it looks like they are perfect. That means they are 100% no loss. But the actual story behind is the airline was losing 80% of the luggage which they processed, and they improved this to only losing 40% now. So obviously, if you are now only losing 40%, they have improved 100%, correct? But that does not mean they are doing better. They are still losing 40% of the bags, which is not good, right? So this may sound very impressive and make people think that they are doing a great job, right? Although they are actually losing 40% of the passengers' luggage. So this kind of misleading statistics appear a lot. So maybe when you're looking at statistics next time through advertisements or whatever, you must start questioning yourself. Can we see more data? If not, then just don't believe those things until you have the actual data. Right, misleading pictographs. So this basically means, people are very picturistic. That means sometimes they like to see pictures rather than reading text. So when you have pictures like this, it can mislead, if you do not look at the data itself. So people like to see, oh, big, that means a lot. Less, small, that means very less. For example, here, the size of area of the dollar coin graphic is misleading. The dollar value differences represented are exaggerated. That means the size, for example, when the size doubles, the coin size doubles, we expect that the coin value also double, all right? But in this case, if you see, in 1980, the quarter is like 1/4 of the size of the coin at 2000, right? So 2000 was this much, right? And in 1980 it was $1, right? But look at the size of it, and in 2000 it is nearly half of that in 1998 and 1980, but the coin is like 1/4 of what you see in 1980. So these are misleading pictures, right? So if a person doesn't bother to look at the data, then by looking at the picture, you will get a different information, or you will start making decisions differently. Okay, so these are considered misleading pictographs. Okay, obviously the third one is something that I've been always telling all of you, which is bad sample. A bad sample is basically will generate not reliable results, right? And basically those data or whatever conclusion you make out of it will be useless, all right? So convenient sampling is one. The researcher chooses a sample that is readily available in some non-random way, right? As what like I explained before, just because you are doing University Malaya survey, a survey that involves University Malaya students, you just give it to your students or your friends who are in the statistic class, because that is the most convenient to you, right? So that is considered convenient sampling, which is not reliable at all, right? Voluntary response sample, that means the researcher puts out a request for members of a population to join the sample, and people decide whether or not to be in the sample. So basically you are like, okay, if those who might be interested or who have passion towards the research or the survey that you're doing, they might volunteer, but other than that, they're not going to volunteer. So most probably the results that you're going to get will be supporting whatever that maybe you want, right? Because the person is going to come and answer your survey are those people who are already interested with that kind of study, the study that you're doing, right? So this is also not advisable. Okay, I think that is all that I wanted to share for tutorial 5. Try to once we upload this, try to look back at some of the YouTubes on this sampling and try to explore some of the other methods in terms of misuses of statistics that is used currently, right? So, okay, that's all. I think I will end my presentation for discussion for tutorial 5 today. All right, thank you very much.